So I don't think I will be giving a lot of seminars in this group, but Michael asked me to give a little bit of a perspective of how this group fits into the overall domain of methods within political science. And so thinking how can we best present what is computational, what is methodological, what is analytical. I've been working in the field for about 25 years, and my identity has been changing with every new buzzword that was introduced into the field. So I've survived big data, data science, I didn't remember, business analytics. So my degree, which is actual decision science, is now called business analytics. It's much more of a buzzword, much more attractive than decision science. But in the process, I think what has happened is that what happened to be a battle of definitions, especially with data science. Anyone is data scientist nowadays. And it could be data engineering, or it could be, data analytics. They're all data scientists, and it's very hard to disambiguate. Well, that mixture and that battle of definitions also propagated to terms like computational and AI and machine learning. And even within our own group, we had a discussion, what is machine learning? So in an effort to try to provide a clear structure for this group methodologically, we put together a map of methods. I did not do it by myself. Dmitry helped me because I don't have enough understanding of the field to put the right methods together. So basically, this is a little bit of a map. And let me see if I can minimize this field so you can see it a little bit better. So this is a little bit of a map that shows families of methods that are used to study political science problems. And they're somewhat connected together. I mean, we can just take this qualitative and mixed, and here are all the methods, and when you hover over it, will tell you what it does. This map was created specifically for this seminar. We don't really know what its place will be. Maybe it will just a presentation today, or maybe with your help, we will create a more comprehensive map and put it on the website for people to take a look at it. The large variety of methods available. So this is not comprehensive. This is not entirely accurate. Some of the connections that are built here, so if you look at descriptive and exploratory data analysis, it's connected to almost everything, right? Whereas spatial and spatiotemporal, not so much, but maybe it should be. So the connection between those groups is really based on, can we study one problem using a variety of methods? So this is not complete by any means. And the one thing that we wanted to clearly define is, what is this group going to do? And this group is really focused on computational methods. And computational methods, we are going to provide the definition. But I think one important distinction is, I'm going to make this map smaller, but anything that this group is interested in, the labels are provided in green. So this entire natural language processing, text to data, images, etc. group, it's all done with the modern computational machine learning AI methods. Predictive analytics has really graduated into having AI machine learning in almost all the methods that were there. We're going to quickly go over these groups, but before we do that, I think it's important to give a context in terms of what we put into the definitions and what I personally mean by things I say. This may or may not be true, this may not be accurate, and may not be agreed upon in political science. That's how I see the world from my evolution from decision scientist to data analyst with all the big data and in between. So let me start the slideshow. Talk a little bit about what is the defined category? Artificial intelligence, and that is, it is a definition that I'm going with. It is the capability of computer system or algorithms to imitate intelligent human behavior. Now, this, may or may not be always accurate because different people think differently of AI, but computer systems perform tasks that normally require human intelligence. For example, reading the text and summarizing it. It used to be that only humans could do that. Now machine reads it, and sometimes it could provide better summary than I could, sometimes not. But at least it's trying, right? So it's capable of making this task. Its core abilities are perception, which means it can extract information from the data given to it, it's reasoning, and I probably should have put reasoning in quotes, because it's not really sitting there and thinking, how does this all fit together? It uses a complex system of probabilities to find the most likely next word that comes after the first word it sees. However, it's capable of learning, and again, we can put this in quotes, because what is learning? It's generating an outcome, going back to the original source and checking, is this outcome working? So there's a lot of back propagation, meaning a capability of machine to adjust its own decision based on the information given. And so the decision making, so basically all of these things are in quotes, right? So the decision making is the outcome that the machine generating responding in well enough to the original. There are lots of different measures that are being used. There are lots of different methods within this domain, but things that humans used to be able to do now, machines can do. They use different processes for this, but the outcomes, if you compare a human summary with a machine summary, sometimes you cannot tell the difference. So the goal is really flexible problem solving. So unlike previous computing that we were dealing with, we had very rigid 0 or 1. There's a lot more flexibility there. Now, there are lots of applications. I mean, the most obvious one is self-driving cars. There's a lot of decision-making that's involved in a self-driving car. Speech recognition, natural language processing. I think that one is the easiest to explain because everybody has at least heard of ChatGPT, if not tried it. There's lots of other forms of generative AI. It's not just text, it's images, it's movies. Having been listening to what you guys do, you are dealing a lot with fakes, right? And all of the deep fakes and all of the misinformation, disinformation, malinformation that's being generated thanks to AI. And then, of course, personal assistants that now, I don't know if we have the Zoom meeting recorded, but sometimes you can turn this on, and by the time you're done, it gives you a summary of what you have talked about. Some robotics is also AI. We're not even doing robotics much in here, so I'm going to skip over that. I think there's also a little bit of confusion about what AI is versus what AI is not. So sometimes it helps to talk about what AI is not. And, programmable thermostats. They call this a smart house. Smart house, I would argue, is not really AI. It's a mixture of the system because there's a difference between smart versus intelligent systems. Again, it's a matter of definition. But programmable thermostats, traditional vending machines, simple macros without interpreting context. And basically what unites them is there is no perception learning or additional adaptation beyond executing a task. So if the task is executed, for example, with a programmable thermostat, temperature drops, thermostat kicks in. Temperature rises, thermostat stops. So that's the only thing it does. It doesn't think, well, is my human comfortable and should I increase humidity at the same time? At least not yet. Okay. So also there's a lot of, now we call it simple software. It's actually quite sophisticated with no adaptive feedback. When websites, when they display the same content to every visitor, or classic video games, or electronic toys. So basically the intelligence that's part of the artificial intelligence requires dynamic response. So it has to adjust its response based on the feedback received or the prompt received from the user. Now, there are borderline cases where it's smart versus intelligent. So chatbots with limited scripts, I don't know how you guys are doing. People think that we're going to eliminate human assistants from the big systems, but I hate talking to chatbots. My prompt always get me a human agent. So most of them are rule-based, and they will only, they will keep sending it through the same loop. Oh, I don't understand your response. Here are the options again. So that's not artificial intelligence. Adaptive cruise control. So I don't know if some of you have this newer technology when your car is driving behind another car and the car adjusts based on the speed of the car before it. It's a smart system. It's not an intelligent system because it's still a system of 0 ones. Is the distance equal to 30 feet? If not, slow down. It doesn't really predict what that driver is going to do. So it's a little bit different than intelligent system. Even advanced search filters that are implemented in our inboxes, or some of the systems we're so used to, like autocorrect, right? So it depends on how you use the autocorrect, but most of it is really a smart system and not intelligent. So the AI claims whether it is AI or not. We just basically have to take a careful look. Does it have perception, learning, and autonomy in decision making? So, and that would be an AI. So that brings us to the next question, what is machine learning? And we had a delightful discussion on Tuesday where John was bringing up things that, well, logistic regression is now called machine learning. So I don't think we'll agree on things. I mean, there will be camps that think that logistic regression is machine learning, but there's distinguishing characteristics of what machine learning most likely is. And again, its ability to learn and adapt without explicit instructions. So in our context, machine learning is processing the data and providing us with a function that generated the data without us giving it any kind of input. I mean, the machine learning could be supervised, unsupervised, semi-supervised. I mean, there are all of these different groups and subclassifications, and even regression. And I think there's several dozen of groups of regression methods. So all the boosted regression is now machine learning, where all else obviously is not. So the idea behind this is we're using algorithms and statistical models to draw inferences from data. It is data-driven. It requires data. The more data, the better. So that is really one of the discussions we also had where the big data plays a role in that. Most of the computational methods we're using do require large amounts of data. And so a different context to think about traditional programming versus machine learning, it used to be that you had to have data and you had to write a program. So you get this data, and then here's the regression equation that should get me the output. Tell me if this variable is significant or not. So that was traditional programming. Now we're saying, here is the data, here's the output. What is the program that can connect the two? So we don't know the function. We don't say that democracy is equal to voting plus parties plus whatever. We don't know that. We're telling machine, I want to understand what the data is telling me. And then that brings us to computational social science. So this is where I think we're going to have the most disagreement, because you guys probably, those especially you who find yourself as computational scientists, might argue with me. But we are trying to understand individual actions and interactions and how they generate macro level social patterns. We are using computational tools that extend traditional qualitative and quantitative methods. It used to be that you were either qual or quant. Now with AI methods and everything that's available in natural language processing, all the qual researchers are becoming quant researchers with a much deeper understanding of what's going on in that data. So it includes data-driven analysis, model and simulation, machine learning and AI. Throughout most of the presentation, I'm going to use machine learning and AI almost interchangeably, because it's very difficult for me personally to distinguish, oh, this is AI and this is machine learning, which is a subset of it, right? So I don't do that. It's just AI/ML. With a slash. Network and complexity science, because I also define myself as a network scientist. I have to put it out there. And then causal and interpretive inference, which is a big part of what you guys do. My job is typically done when I get the model done. I get the model, I'm happy. Your job starts at that point, right? Because models are models, but you have to understand the complexity behind them. So I think that brings us to what is computational in our research group. We are focusing on estimating non-solvable statistical models, and those are the problems that don't have the closed-form solutions. So it's not, we are focusing on estimating problems where we can't just say, this is the regression equation, give me the output. And I'm sorry for picking on regression, it's the method everybody knows. We're going to use newest AI/ML methods to draw inferences from the data. We're going to focus on theory-driven resampling, bootstrapping with a lot of data. So it is data-driven. It is computation-driven, and for us, computation is everything that does not belong to a domain of an easy formula already created by this function. Now, I'm going to stop the presentation for a moment and take us back. Ask again. Take us back a little bit to this particular map. So if you look at, so basically everything on this map that has green labels is the domain of interest of this group. Now, I'm not saying that we're not interested in, say, multivariate and dimension reduction, especially because AI/ML-driven string techniques are a big part of it. We're not interested in computational simulation, longitudinal time series. I'm not saying that. I'm just saying that the main focus from a methodological perspective is on those methods highlighted in green. Now, Michael gave me a very difficult task to take this map and break it down on a level that's not only makes sense, but also applicable to this group. and I am sad to report I failed in doing that. So I just passed this on to Dmitry and said, here, you do it, because I see the methods. It's very difficult for me to see through how do they all fit together. So I'm going to pass this on to Dmitry to talk a little bit about how this all fits together. And then I take over the mouse again and we'll talk about it.
Yeah, if you want to hide it, you can click on more and then yeah.
Yeah, as Vale said, we were thinking about the framework actually that we can organize somehow all these methods that we have. It goes on under the label and non-computational actually. So, and the second task from Michael was to distinguish between computational methods. So, because our group is about computational methods, so what is computational methods actually? So, another disclaimer that again, that I just said that we are talking only about our opinion. So, this we do trying to agree between me and Vale. Okay, so, and the next step, I think we have some agreement in our small group. Now we just propose you our vision on this, and we're all social scientists, and the first step we know that when we work in the groups, we're asking ourselves, let's agree about terminology. What do we mean by this? So it is a kind of first step toward this, so it's a long way. So, and trying to provide some kind of framework that can organize all these methods, I take this circle of political research that everybody knows, students about this, that we're starting from conceptualization, generation, and personalization, that go to test association, measurement as of association, and causal inference, and again, so now this is like a classical path in research in political science, and it actually doesn't matter how you call it. And the idea here is that I will give several definitions. Yeah, so computational methods are those methods that go beyond the circle. So, and next slide, I will see that actually we can associate with each stage, we can associate some method, like with
You have to click on, like, use the mouse to click on the, not the mouse. Not the mouse, yeah.
So we have some kind of association. For example, for conceptualization, it's not here strong relations. It's kind of what we usually mostly frequently use for conceptualization. For conceptualization, we use actually qualitative methods, different qualitative starting from literature review, providing some narratives, maybe go do some interviews to understand it, to build our theory. Yeah? Mixed methods are somewhere here as well. With personalization, the descriptive data and explorative data analysis are closely associated. So we want to choose variables, we want to play with data, we want to build some distributions, whatever. On the measurement stage, we have different procedures like structural equation modeling to build measurement model and to understand what is the latent construct. It's can be factor analysis or something, multivariate dimensional dimensionality reduction. If we have too many variables that are correlated with each other, we use principal component analysis, for example, on factor analysis or something like this. Test for association. Here we have classical parametric inference methods. Yeah, that's tools that usually kind of based methods. And here the most interesting thing started because causal inference actually, can I go back here?
It's on the other.
It's not a keyboard.
Yeah.
This keyboard. So here's the most interesting part started. This where actually the demarcation line between computational and non-computational methods started in causal inference, and we have a lot of fights with Mario on this. What causal inference methods actually are non-computational, what are them are computational. And the idea why we are going beyond is that till this point, we are trained as a social scientist that we're interested in, first of all, in causes. We're interested in why question, why this phenomenon happened, what are the causes that determine a certain effect, determine certain phenomena. To go beyond this, you have to go beyond this logic, because you have to understand, for example, that causes in the same time can be consequences. So you are not certain about what are really causes and what are really outcomes that you study. So here the tricky thing appeared, and this is how you go beyond computational methods. And if you take causal inference methods, for example, we have simple regression-based methods here. First of all, demarcation lines exist in longitudinal time series analysis. When we have regression-based model and AIMA, this is something that's still in the logic that we know what are the causes, what is the effect, and we want to prove that these particular causes lead to this particular effect. Starting with such methods as vector autoregression, then structural vector autoregression, then state space models, longitudinal SAM, we don't anymore assume that we are certain about the certain causes that lead to certain effects. So we are into the complexity. Complexity meaning that everything is connected with everything, and sometimes in some point in time, this amount of things can be cause this effect, and then it can be vice versa. And what was causes can become an effect. And such methods that deal with complexity are computational methods. So this is the additional definition. So we have classical methods that are here, that is classical descriptive and inferential statistics methods. And then we have more complex computational methods, advanced methods, you can call them, or that are dealing with complexity and starting with prediction. Prediction, then relation as a unit of analysis. This is a different kind of social network analysis, network science with here relational data methods. Text is data, including NLP, LLM, and all this stuff. And effectiveness, efficiency analysis. Maybe more you can add here, but this is what we can do. Yeah, and again, both the demarcation line lays somewhere here. And classical traditional methods that or non-computational methods, and here we have computational methods. So,
with that in mind, I will probably take this keyboard and the mouse so I can see very well. So I'll try to stand right here so I can control this a little bit better and not turn my back on you. We can go back. So the methods listed here in the research cycle stages. So the groups of methods correspond almost exactly to the groups of methods here. They might be named slightly differently, even though we try to keep them about the same. So I think text as data is named text, images, and digital traces. So basically, these are the groups of methods that correspond to the research cycle before causal inference and research cycle and research outside the causal inference. So in this particular setup, I'm going to go back to the map. and make it a little bit larger so that we can see the groups of methods that are present. And so if I hide them all, it makes it a little bit easier. And if we start with descriptive and exploratory data analysis, which comes in early in the research process, this particular group, I'm sure most people are familiar with, at least with some of the methods. We have our typical data structures, types, measurement levels, when we look at what is the data material. So, and sometimes in the descriptive in the we might be dealing with text data. It doesn't have to be just numerical data, but any type. So we break it out in different types based on the problems that we are dealing with. And then we move into data viz, and then data visualization, then data storytelling, how to present our data everywhere belongs to this larger group of methods. We can have distributional summaries. We look, is this data parametric? Does this data have measures of central tendency, or this is some kind of a non-parametric distribution, which means it does not really fit any known distribution. So that we cannot calculate the standard deviation. And we have to use methods that are non-parametric. And so there will be different multivariate descriptions, summary and robust description methods. So this is that first group that fits into their first block of the research cycle. So now going through this, I don't know if I want to go through every single group. I think what I will do is I will just click on the traditional, or what I consider traditional social science research methods. And as I do that, so when I go into measurement and psychometrics, where we develop scales for measuring, should make this a little bit larger, right? Just a little bit. When I go into classical inference, and classical inference, I did take ordinary least square regression out of the generalized linear model, just because it's used so much, and that's what statistics is typically taught with. But it's not a separate group of methods, right? So it belongs to the general linear models. And so we have survival and meta history, we have hypothesis testing, we have interaction moderation. Then we go into, maybe some multi-level. That is a relatively popular method in political sciences, and that includes structural equations modeling, some Bayesian multi-level. And so as I am adding these methods, some of you are doing spatial analysis. So we're looking at geographically weighted methods. How does different locations, affect certain outcomes? I mean, I'm making this up as I go. So as I am adding these classical methods, right? So we also have the qualitative and mixed. We put them in one group, not for any reason other than there wasn't enough place on the map. You can break them up. We can have a pure qualitative method separately from, again, based on your feedback, guys. And again, there is a large group of methods here. Notice that as I'm putting these methods on the map, nothing here is green, right? So none of them really involve computational AI machine learning based. Computational AI machine learning starts to come in as networks are here too. They're also not computational AI. Even though they do use a lot of simulation modeling and computational simulations is, that's that one programming where you give it a specific structure and it's gonna always run the same way. You might get slightly different outcomes because you start with a different seed, but it's only the random seed that controls the outcome, not the learning from the data. So those simulations and computations are not AI machine learning, and they're not of that much interest in terms of development for our group. So, however, as Dmitry said, as soon as we move into the causal inference, this is where the breakdown starts to happen. So causal inference, we can have causal graphs, causal mediation, quasi-experiments, some longitudinal causal analysis. But this is where machine learning first made its entrance. This is when we first started to learn from the data. And I don't know the history of AI ML. I don't know when these methods were first introduced. John is really good at that. He will give you the dates. I know the coin was turned in 1956. That's the extent of my history knowledge. But what has happened with machine learning is we had data that was causal in nature, let's say longitudinal in nature. And the machine was learning that the outcomes it was getting were not accurate. So with new methods that were being introduced, the machine started to self-educate, right? And create better models and become more accurate in terms of fitting the data. And so here we started to get into this causal inference with G methods, machine learning augmented causal and the causal inference. So that's where the demarcation line comes in. And so all other groups of methods, when we go into predictive modeling, it's right there, it's up on top. It's all by itself. Better than everyone else. So that one is entirely green because everywhere, no method and method. So if we're looking at forecast and forecast evaluation, we now have AI-based methodologies, machine learning-based methodologies for evaluating how good the forecast is. For margin-based and instant-based predictions, we now have machine learning methods. Regularization, obviously. I mean, even though lasso has existed forever, now it's lasso on steroids, and it's doing so much better. Time series forecasting, of course, I think that's where it started first, but trees and samples and force. So all the methods that the traditional, at least groups of methods, I mean, obviously when we go into each one, we have a lot in each one of them, right? But basically, in each of these groups of methods, there is at least some AI machine learning based methodology. So predictive modeling is almost entirely belonging to this particular domain. Now, we also have multivariate and dimension reduction. It used to be a domain of classical analysis because, we had principal components and exploratory factor analysis, confirmatory factor analysis forever. But then, of course, machine learning comes in, and now we have a lot of machine learning-based clustering techniques that are quite different from what we were used to in traditional statistics. But clustering does not necessarily belong into that research cycle. I mean, some can argue that you could put some clustering into exploratory data analysis. But again, if it is exploratory, it's really not the decision-making thereafter, right? So it's not really looking for some inferences in the data. So when we're looking for inferences in data, it goes beyond causal and goes beyond the traditional classical. So there are a few things here that I have missed. One of them is meta-analysis and evaluation. It is being used. I'm starting to get lost. Here it is. Okay. So there is there is lots of meta-analytic methods, obviously, but I don't see it being very popular. I think in 2010, the University of Iowa, which is really big on meta-analysis. You could not graduate from Iowa unless you could do meta-analysis. So I think all of the meta-analysis published by people from Iowa. But anyway, that kind of died down. Just like structural equations modeling was really hot about 20 years ago. But it's a group of methods, again, it has a particular purpose, but it's not necessarily fitting into that research cycle. Well, actually, it is fitting into the research cycle up until we get to the causal, because some meta-analysis summarizes what did people publish on this, locally, what did people publish and so on, right? So I'm also missing longitudinal and time series. And for this particular longitudinal time series, we have separated from predictive models because a lot of longitudinal time series analysis in this particular illustration is really descriptive, or it is more inferential from the causal perspective, like why did this happen, right? We're not looking at expanding it further from the methods that are presented in this group. So univariate time series, multivariate time series panels, state-space and Markov analysis, Markov chain sequence analysis. They're not necessarily computational. These are traditional statistical methods that we always had as part of our chess. So same goes with Bayesian. And somewhere I've heard that all people in this world are divided into Bayesian and everyone else. So if you're Bayesian, you do have potentially some inference agents that could be machine learning augmented. I don't know enough about CMC to know this simulation model doesn't really learn. If they start creating new algorithms in addition to metropolis castings, then maybe it would be machine learning. And maybe there are already some. I haven't done that work, so I'm not really quite up to date. But Bayesian methods again fit into the overall. So we have two group of methods left. One is that everyone is familiar with, no matter whether you because ChatGPT did a good job of getting us all excited about the possibilities. So it's, text, transformers actually belong in their own group because transformers such as ChatGPT, they are tools that are available to us that we can use without any need for program. We just talk to it. You say, well, create me a Python code for this, and it will do. Now, text as data could require some work on our dictionary methods, for example. Or we're going into more advanced modeling that ChatGPT cannot do, right? So when we have to train our own models for that. So that's why they're separate. So transformers is a separate group because it's both a method and in an instrument, and it's both an outcome output. So also images sensors, again, notice they're all green. So we are all excited about using that stuff. And one more that's left that we have not covered is null and semi-parametric. That is one of my most favorite groups. I have lots of hope for it, even though it doesn't have anything green, doesn't mean I'm going to abandon it, just because it does so much of interesting stuff. So for example, efficiency and productivity estimation. I'm not making a political statement, but when Trump created the Doge department, they did not do this. Okay, they did not ask us, how do you really become more efficient, right? So these methods in political science, they're not used much. We've only seen a couple of studies that apply those efficiency estimates, because people really don't like, how do you become more efficient in politics, right? Well, I don't know much about politics, but I do know that you have to run the government. You can run the government efficiently. So obviously these methods have that hope. So there is a large group of methods that really are focused on data that does not have any distribution. And we cannot fit a normal distribution or Poisson distribution. It does not have a distribution. It has data sporadically just spread throughout, but it doesn't mean we can't analyze it. Typically we can, right? We don't make any distributional assumptions. It doesn't mean it doesn't have a distribution. Every data has a distribution. It means that there is no known distribution with parameters that we can assign to it. But there are lots of methods that help us model that very complex data, and a lot of it's in political science. It really is. I think Trump is very helpful at generating this data for us right now. So if any doctoral students are interested in efficiency of Trump's government, that could be the way to go, right? So, and then that is kind of, did I show everything? Yes. So this one was last but not least. And so I'm going to talk for a moment and have you ask questions, offer suggestions, which is going to give you a chance to talk.